So what you might want to do now that you understand how to draw vertexes, draw shapes using vertexes, is use random to generate some random numbers. We've got a simple random call here that says make me a number between 0 and 4 by saying float x equals random 4. We also have another one here that says generate random number between 2 and 42, and we've got two arguments here, random 2, 42. So we can make some interesting things here with adding some randomness to the numbers we use in our vertexes. So we've got a normal set of vertexes here, but just we're adding randomness to those numbers we saw before. So if you compare this one to the rectangle plot, you'll see it's actually similar except for these bits, which come from here, so that's also been added. To have a look at that, that's randomized quadrangle plot, this one. You can see a bit more code, but it's basically the same structure as the original one. We've got two extra arguments saying 0.2 and 0.2, which are used to multiply this and work out what's a good jitter value, what's a good range. So now our rectangles are wonky. They're all over the place because we're adding jitter. So review that. That's great fun, by the way. That's what a lot of processing sketches use. They create texture and through using a bit of randomness. Now this week we're going to create a function which can draw any polygon by doing a little bit of smart trigonometry. So how do you state I want 7 sides and I want a polygon of this radius? You need to understand how where to put each of those vertices if you're to do that. So there's a couple of things you need to know. There is good old SOHCAHTOA, which is the sine of the angle here is equal to the opposite, the length of the opposite divided by the hypotenuse. The cosine of that angle is equal to the adjacent divided by the hypotenuse. The tan of the angle is equal to the opposite divided by the adjacent, and the tangent of that angle is equal to the sine of that angle divided by the cos of that angle. So that helps you to basically work out where to put each of your vertexes. I won't go into too much detail, but I think this will be an interesting mathematical challenge. This is Year 9 maths, I think, maybe Year 8 maths. It's not too difficult. It's quite straightforward. So looking at on the unit circle, you can see here that the origin is here, and we want to know how big should our x and our y be for a given radius. Well, x equals the radius times the cosine of the angle. So that x value here, that width there, is the radius times the cosine of the angle. And the y value is the same, except it's the radius times the sine of the angle. Now, don't forget your conversion between radians and degrees. If you're expecting degrees, you need to turn radian values into degrees by this formula, and if you're expecting radians, you need to turn degrees into radians by using this formula. So check what your code is looking for and then make sure you're giving it the right values. It's a very common mistake. All of your angles go wacky and you can't make anything work because you're dealing with radians instead of degrees. So let's have a look at draw a circle and draw a polygon. So then we just need to find that file. 3 demos. Draw a circle is here. So here's a circle drawn angle by angle. So we're going to say the radius is 200. We're setting up a window. Then we're going to begin the shape, and we're going to do this 360 times. We're going to say x equals radius times cosine of radians angle, and remember angle starts at 0 and goes to 360, and y equals radius times sine radians of the angle. So does cosine expect radians or degrees? Well, we can work out that it's expecting radians because this code is using radians to turn degrees, 0 to 360, back into radians so that cos can use it. There we go. It's drawn a nice little circle for us. Very simple. You can see that it goes all the way through that list using the for loop, vertex by vertex by vertex by vertex, and then it ends the shape and closes that off. So that's a shape with 360 vertexes. So that's quite a lot of vertexes. Now we can also draw a polygon. Here's our polygon example. So here we'll say side count by radius. And we're going to divide the angle increment by 360 divided by side count. Here we're looking for a 5-sided polygon with radius of 200, but we could easily change that to a 9-sided polygon and get a 9-sided polygon very simply because we've done the maths here. And notice the maths looks pretty similar, doesn't it? What's the difference? Well, if we look at the circle, it's just in this for loop here, isn't it? In the for loop it says angle equals 0 up to angle is less than 360, so that's go all the way up to 360. Angle plus plus by ones. Here we're saying angle equals 0, angle is less than 360, same deal, except we're saying angle plus equals angle increment, which means angle equals angle plus angle increment, and angle increment equals 360 divided by 9 or 5 or 7, so a big chunk. So instead of us going by ones, we're going by 65s or 70s or something like that. So we're jumping up quite rapidly, stepping through those increments. That's how to draw a polygon. So when we're drawing these polygons, it's quite complicated to then draw those polygons in a particular location by adding offsets all the time. So if you wanted to draw that polygon up in the right corner, you could add a certain value of x and a certain value of y to every single vertex, but that's kind of annoying. So we can use transformations to draw everything around a particular center and translate that across. So if we look at draw polygon translate, I think you'll see what we mean. So there's draw polygon translate. So here we're going to translate this width divided by 2 and height divided by 2. And so if we look at this, we're going to get the same outcome. But notice here we had to add width divided by 2 and height divided by 2 to make it go in the middle. And if we left these out, I can just comment them out, what happens? It'll go up in the top left-hand corner there, around the origin. Whereas this one, we've said just move your point of drawing into the middle of the screen and then just start drawing. So that's probably an easier process for drawing. You just move your, basically your draw head, so to speak, to wherever you want to draw around, and then you draw around that particular point with by drawing like it's the origin. You can also rotate, and that's draw polygon translate rotate. That's this one. So here you can see that we're it's this one actually. We've rotated as well as translated. So we can now draw a polygon that rotates each time. Now the rotation angle here is being added to. You can see rotation angle plus plus. So every time we draw this polygon in this draw loop, which happens forever, remember, we're adding 1 to the angle, and then we're rotating by that value. So every time we redraw this screen, we're changing the polygon. So start to use those transformations straight away. They're quite important. Here's a quick example of the different types of translations you can do. Don't forget, transformations are cumulative. So if you translate and then retranslate again, you continue to move. So if you want to get back to the top left-hand corner, you have to translate back from where you translated to. Now here, we can also use pushing and popping to save the current drawing context and revert to the previous drawing context. So we can translate to a particular location, save it, and then jump back to the previous location. So here is an example of doing that. We can say push matrix, translate, draw polygon, and pop matrix. That's the usual way we do things. We say, remember where we are, translate somewhere, do something, and then put us back where we were first. So this is going to create lots of polygons. Now let's have a look at this. So here you go. Polygons all over the place, because what we're doing is we're saying make 500 polygons, translate to a random location within width and height, width being the width of the window and height being the height of the window. Then draw a polygon between 3 and 12 sides that has a radius between 20 and 60, and then go back to where you were first. Forget this new translation. So that makes sure that every time you translate, you don't have to untranslate manually. You can just call pop matrix and go back to what you were using before. But remember, if you call pop matrix, you have to have pushed it. You have to have saved it to go back to it. Okay? So that's quite useful. So hopefully you now understand functions and methods. Showed you a very simple function, but we've looked at quite a few, and you should dig into those examples to see the functions. Hopefully you know about setup and draw. Hopefully you're able to draw custom shapes in processing, and also remember basic trigonometry and understand why it can be useful. So to do this one, dig into that polygon example, because that's going to be critical. Using that basic Year 9 trigonometry is going to be really helpful right throughout this course. Alright, thank you very much.